Alright, so we're looking at 1-2 transformations of functions. We got some vocabulary here like compression. So a compression can either be vertical or horizontal. It can be one of the two. If you talk about a vertical compression, it would take a graph, and I'll just do absolute value, and it would literally just shove it down. It'd push it down. You talk about a horizontal compression. So horizontal compression, you take the same graph of absolute value and you do the horizontal compression and it pushes it together and makes it taller. So a compression and a stretch are kind of like opposite actions. That's what they are. They're opposite of each other. But they end up doing kind of the same thing to some degree. Of course, we should know what a reflection is, where you flip over the x-axis. These are all types of transformations. Your translation, that's where you commonly see a teacher talk about shift left or right. Or maybe they say up, down. So that's where that comes from. Alright, now I am adding on to the form that I've been showing you for the last 2 weeks. This is the full form, full transformation form. It's a of f times b times x minus h plus k, where f just stands for function. So you can think of it like this. 2x, let me put something else, 3 times x minus 2 quantity squared plus 4. The only thing that's really new to y'all would be that 3 in there. That's really the only thing that would be new to you. You should realize that the exponent's a 2, so you have a parabola. You should, doesn't mean you do. There's about 20% of my students who hadn't quite connected dots on that. But this is the full form, so now is where it starts getting a little rougher. Okay? I don't think it'll be too bad. Like when I test and stuff, I probably won't talk a whole lot about horizontal, which is the B term. But there is a lot going on. All right, A, we've talked about A. A hasn't changed. A is initial slope. If it's bigger than 1, you have a stretch. If it's less than 1, you have a compression. If it's negative, you've done a vertical reflection. And that may or may not be a reflection over the x-axis. It depends on what's going on. In fact, I actually want to delete that out. That may or may not be. It all depends on how things are presented. It's not necessarily a reflection over the x-axis, but it is definitely a vertical reflection. All right, moving on to B. B is new for y'all. B is inside, and if you're inside, you're with your x's, so you got to be a horizontal idea. So it is the horizontal stretch or compression, and notice that it's reversed. Up here, if A was bigger than 1, you had a vertical stretch. That doesn't seem right. I got to think about that for a second. Something seems off on that. Yeah, this text is backwards. I'm glad I caught that. Now whether I fix that before class starts, who knows. But if B is less than 1, you have a stretch. You have a horizontal stretch, which is equivalent to a vertical compression. Yeah, that's right. And if B is bigger than 1, you have a horizontal compression. All right. If B happens to be negative, you have what's called a horizontal reflection. And it's not necessarily a reflection over the y-axis. Alright, so I'm glad I'm catching these little things. And the real question is, do I fix it before class time, or do I forget all about it? I'll probably forget all about it. Alright, H is inside. It's the horizontal stuff, and it's inside. It's with X. That's why it says think input, because X is input. And H is the horizontal shift. It's always opposite the sign. K is outside, so think output, which means it affects Y. It's the up and down stuff. It's the vertical shift. And there's your notes on that. Anyways, reflect the equation x squared plus 4 over the x-axis. So the function rule for reflecting over the x-axis is rather simple. So I'm going to write it down. To perform an x-axis reflection, the function f of x gets negated. We'll create a new function. Your book often uses h, so I should probably switch over to h. The new function called h of x is simply negative f of x. Now notice that the negative symbol is talking about the entire function, not just a piece of it. And that's kind of the thing that catches kids, is where do I put the negative symbol? And I'll talk about that. But anyways, we negate everything. We don't just negate a piece of it. And if we distribute that negative, we'd have this guy right here. Negative x to the second minus 4. Now let's take a quick look at Desmos and make sure that Milbrath is thinking right, because Milbrath is very tired. I know you're tired when you refer to yourself in third person. Anyways, here's x squared plus 4, which is the original function, and if I negate the whole thing, I should have an x-axis reflection. And you do. Hopefully you understand that that is an x-axis reflection. Now, a very common mistake is for a kid to just negate the x piece. And if you just negate the x piece, you did a vertical reflection. So be careful about what you negate. For a full x-axis reflection, you have to negate the entire function that you're given. So pay attention to that. Anywho, reflect the equation f of x equals x plus 3 quantity squared over the y-axis. Now, these can be fun, and this is a square, and I don't know that squares are the best thing to teach about horizontal reflections. To do a y-axis reflection, all you have to do is negate x, because now it's taking all the positive numbers and making them negative that you feed it. I don't know if that makes any sense to you or not. But I can tell you that a common mistake, and one that I would make, would be to say that the new function is simply the old function with a negative inserted on the inside. And I would do this. All day long I would do this. It's just what I do. And I know I do it, so I have learned not to do it. But let me show you what I did. I inserted a negative on the inside because that's B. B is the horizontal idea. Now what's happening here is we square the things, and suddenly that negative becomes a positive. Now, the original function was this. If I negate everything on the inside, I didn't accomplish anything. The thing looks exactly the same. So what you actually have to do is simply negate the x, and that causes the reflection on the y-axis. So, to perform a y-axis reflection, you simply negate x, and x only. You don't negate anything else, you just negate x. So the correct answer here, or the correct notation, would be that h of x is simply f of negative x, which means I replace every x I see with a negative x. So I go to my original equation, I see an x plus a 3, and that x becomes negative x. Good stuff, right? It's not all that exciting. And it's fairly high level. It's fairly high level. Usually only kids that test upper level 3 and upper level 4 in math tend to get the horizontal aspects. Alright, graph f of x is the absolute value of x with a domain of negative 4 to 4, and h of x, which is f of twice x. How are the graph's domains and ranges related? So the best way to do this is simply to make a table. And some of you still don't know what absolute value looks like. I mean, I just graded around the mother function quizzes. And I guarantee you, of the 70 some odd kids I have in Algebra 2 this year, 10 of you didn't graph absolute value correct. Anyways, we're going to make a little table. We're going to go from negative 4 to positive 4, and I'm not going to do everything in between. I'm just going to stick with my usual three key points. Now, I know this is an issue, and I don't honestly know how you got put in Algebra 2. But the absolute value of negative 4 is 4. I do know how you got put in Algebra 2. It's called promotion. We keep promoting kids past where they're ready, and I don't believe in that. The absolute value of any number is the same number, but it is positive, because absolute value is a concept of distance. So there's a nice little table there. And the reason I went from negative 4 to 4 is because that was domain. That was my x values. So the absolute value of negative 4 happened to be positive 4. The absolute value of positive 4 happened to be 4. And of course, the absolute value of 0 is 0. And this is a v because it's absolute value. Now, the next thing you're supposed to do is f of 2x. F of 2x. What does that mean? What does f of 2x mean? It literally means you put a 2 in there. So like the original equation was absolute value of x, the transformation would be the absolute value of twice x. So we're going to feed it the same exact stuff, okay? We're going to feed it a negative 4 all the way to a positive 4. But when we actually do our operation, there's going to be a 2 times there. So this becomes the absolute value of 2 times a negative 4. It becomes the absolute value of a negative 8, which happens to be 8. And what's going to happen is all these numbers are just going to double. Take your old output, double it. That's what it does. So at negative 4, instead of having an output of 4, we have an output of 8. And at negative 1, instead of having an output of 1, we have an output of 2, and so forth. So, what happened? Okay, well, let's talk about the absolute value of x and what it was. Its original domain was negative 4 to 4. The new function, which is the absolute value of twice x, still has the same domain. I plugged in negative 4 to 4. The old range was 0 to 4, but the new range is 0 to 8. Now I want you to pay attention that the graph was horizontally compressed. And a horizontal compression is equivalent to a vertical stretch. So pay attention to that, okay? All right, graph a combination of transformations. The graph represents y equals f of x. Using y equals f of x, can you graph a combination of transformations? And you're tasked with graphing y equals negative f of x plus 2. Now, your full transformation form looks like y equals a/f's of b times x minus h plus k. The only two letters they have given you is they're telling you that a is a negative 1 and h is a negative 2. The issue with transformations, first off, is picking out what the letters are, knowing what the letters are, and then knowing the correct order. The correct order to apply transformations, and we have a word for it. So the correct order to apply transformations is Bahak. Bahak, or back, however you want to pronounce it. B, then H, then A, then K. So first, we're going to shift left 2. And you'll see a little hint at the bottom. It says, it is easier to perform one transformation at a time. Trying to perform both transformations will often be wrong, and it is wrong almost all the time. Lots of kids try to do it, and the vast majority of them fail in the process. So the first thing we're going to do is we're just going to shift the graph left 2. And all I'm doing is I'm grabbing a point and I'm shifting it left 2. That's all I'm doing. And I'm going to redraw the graph. Now, pay attention to the next thing. They tell you a is negative 1. And notice how it's talking about negates the whole function. This is going to be an x-axis reflection. What it's doing is it's negating the output. It's taking the output from positive to negative. And I've taught this using tables in the past, but boy, it didn't go well. But think about this ordered pair here. It's negative 6, comma 2. When you talk about being negative f of, you're talking about changing the y value. And that's what that negative symbol does. It changes the y value. If you reflect it over the x-axis, you're still going to have an x-coordinate of negative 6. But your y-coordinate is going to be negative 2. And that's all we're going to do. Like this guy is at negative 4, 4. Now it's going to be at negative 4, negative 4. This dude is at negative 3, 3. Now it's going to be at negative 3, 3. This guy right here is at negative 2, 5. Still going to be at negative 2, but now we're going to be at negative 2, negative 5. And then the last one I have is at negative 1, 7. Going to be at negative 1, 7. And then I just connect the dots. It's not bad. Like, it's really not bad. Is it going to be something that most kids miss? Yeah, it is. And I know it is. I wish it was something I could make click. But hopefully you see it. Hopefully you're not that kid who doesn't. All right, the graph represents y equals f of x. Using y equals f of x, can you graph a combination of transformations? So let's take a look at what letters they gave us, okay? Let's do our lineup process with the full form. A, f's of b, I always forget about b myself, x minus h plus k. And hopefully you can see that they have given us a as a half, and they have given us that k is 3. And they haven't given us anything else. And again, your order is Bahak. So I'm going to have to do a first, okay? Now, a is a half. What does that mean? That means we take 1/2 the y values present. Okay? This is why I said I've taught this using tables in the past. So let's plot a couple of these points that I might need. I've got negative 5, 2. I've got 0, 4. And I've got 4, 2. And I need to do this guy first. This is the first thing I do. And it means take half the y values present. So instead of being negative 5, 2, I'm going to be negative 5, 1. Instead of being 0, 4, I'm going to be 0, 2. Instead of being 4, 2, I'm going to be 4, 1. Now, this one is not going to move. This is at 1, 0. If you take half of 0, you're still going to be 0. And hopefully you can see that it is exactly half the height that it used to be, because with an a value of a half, you're a vertical compression. The next thing to do is k, and k is 3. This is a shift up 3. So we're just going to take each point that we have, and we're going to move them up 3, including this one. And again, try to do these things one at a time, even if you're a kid who's not accustomed to doing them one at a time. Like, I'm going to go with Jacoby. I got a hunch Jacoby likes to try and do a lot in his head. Probably right about that. You're welcome to do it, Jacoby. You are. You probably just miss it. You know, a textbook written by Pearson is telling you this. Do it one at a time. The people who wrote your textbook know what they're talking about. All right, use the graph of f above. Graph each equation. So you're supposed to write y equals f of twice x minus 4. Okay, so let's identify the letters. That's the big thing. Identify the letters. We have y equals af's of b times x minus h plus k. And the only two letters I see here is b is 2, and I see that k is negative 4. Now, just like h was opposite sign, b works opposite of what you think. Having a b value of 2 does not mean that you double the x values. It actually means you half the x values. So with b equal to 2, it means divide the x values by 2. And that's a hard pill to swallow. Oh, that's a hard pill to swallow. Now, why am I talking about b first? I'm talking about b first because, again, the order is Bahak. B-H-A-K. So I've got to do b first. So I'm going to take and plot some points here so I can easily see them and take half. Like this is at negative 6, 2. Wouldn't kill some of y'all to learn how to plot points a little faster. Negative 4, 5. 0, 2. And I'll cut this one in half. That's at 4, 4. Now if I cut them in half, if I cut the x values in half, this becomes negative 3, 2. This becomes negative 2, 5. 0, 2 is still going to be 0, 2. But this becomes 2, 4. And that's the first transformation. A value of 2 is a horizontal compression. It's not a horizontal stretch, it's a horizontal compression. If it's inside a set of parentheses, you're going to end up doing opposite of whatever it says at some point in time. Alright, so next up is k. K is -4. That means we do a vertical translation down 4. So with k equal to -4, we translate down 4 units. Not too bad, I don't think. Fall 4. The fun part's like when somebody asks you to do everything at once. When they give you all the letters. That's when it gets fun. Fall 4. Fall 4. Fall 4. And this kind of stuff actually gives me a headache after a while. It does. I mean, I'm not going to lie. It does. Alright, moving on to B. So that's how you do A. Let's clear it and do B. Talk about what B says. B is f of 2x minus 3. Yeah, B's got 3 letters in it, doesn't it? So again, lining up with my form, y equals a f's of x minus h plus k. The 3 things I see is I see that B is 2. Okay. I see that h is 3. And I see that k is -2. Now, do I need to do something else? I do. See that? That says B parentheses x minus h. So this is not a very good problem. Not a very good problem at all. Let me pause that. Let me make sure I'm following the author's intentions before I modify something. Yeah, I wanted to make sure me and the author were on the same page. But the author of the book gave a really bad example here. Let's make that a 4. So the reason I'm changing this is so I can do a little factoring and make it look better. Pull that 2, make that x minus 2. Okay? And then minus 2 on the outside. So remember our forms? I've seen different authors teach this different ways, but it's a factored form that we use. This is what we're going with. So now, turns out h is not 3. I changed the problem. Turns out h is 2. And what's our order? We're going to do Bahak. Okay? So we're going to do b first. B is 2. And with a b value of 2, we cut x values in half. Cut them in half. So, plot our points here again. I wish I hadn't erased those, but that was -6, 2. If we cut that in half, we're at -3, 2. This was -4, 5, and if we cut it in half, we're at -2, 5. This was 0, 2, and if you cut it in half, you're still 0, 2, because we're only cutting x. And here we were at 4, 4, and if we cut it in half, we're going to be at 2, 4. Always do B first. We've done a horizontal compression. The next thing would be H. H is 2. That means shift right 2. So we're going to move everything over 2 units. And then we're going to do K. That's down 2. So drop 2. Right there, right there, right there, right there. And oh, what a mess, right? What a mess. Now, I'll probably spend another day talking about how to do this with tables. And by God, that's a fun lesson. Not really. It's not really a fun lesson at all. Alright, so the concept summary here is the transformations of function. Let f of x be x squared. Write the equation representing a horizontal shift right 2. Now that's something you already know how to do. You do, so this shouldn't be a problem. Just call the new function something like h of x. Okay? if we're going to shift right 2, we're just going to take away 2 from the inside. So that's all we have to do. It's going to be x minus 2 quantity squared. That shifts the mom function x squared right 2. Write the equation in standard form representing a horizontal stretch with b equals a half and a vertical reflection. So b is a half and we have a vertical reflection. So to make it reflect vertically, we insert a negative symbol out front. Tells me b is a half. I'm going to put a half inside and then I'm going to square. And you know what? We can figure out what a half squared is. A half squared is a quarter. You can turn pretty much any horizontal compression or stretch into something vertical because they are the same thing. They just work opposite of each other. But anyways, if you square that thing, this is what you get. That's standard form. Write the equation in standard form representing an x-axis reflection, a horizontal shift left up 2, and a vertical shift up 3. Lots of things they just told me to do. X-axis reflection, that's A, that's H, and that's K. I want you to remember that the order is Bahak, right? So I'm going to have to talk about this first, then that, then that. And they want a true x-axis reflection. Yeah, that should be good enough. So I got to talk about H first. I'm going to do x plus 2, quantity squared, to reflect over the x-axis, insert the negative there, or do the vertical reflection, and then up 3. Just apply order, Bahak, and go with it. And that's it. And this is a fairly long lesson. I'm not sure what I'm going to do. It's supposed to be Friday's lesson, but it may end up being Monday's lesson. Anyways, if I teach it Friday, I hope you had a good weekend, or I hope you have a good weekend. If I didn't teach it Friday, I hope you had a good weekend.